Hello dear students, I am Dr. D.C. Saxena, Professor and Head of the Department of Food Engineering and Technology at Sant Longowal Institute of Engineering and Technology, Longowal. I am here to present the paper Technology of Meat, Poultry, Fish and Seafood Products. Now you know that there are different products based upon the moisture content. This comes under the intermediate moisture product and dried products. Now, in this module, you will be knowing the technology of intermediate moisture and dried meat product by my co-author, Ms. Romi Jan.
Hello students, welcome to EPG Pathshala. I am Romi Jan from Sant Longowal Institute of Engineering and Technology. Today, I am going to talk about Module 15, Technology of Intermediate Moisture and Dried Meat Products of paper number 8, Technology of Meat, Poultry, Fish and Seafood Products. In this module, we will learn about the technology of intermediate moisture and dried meat products. Drying is the lowering of the water activity in the meat and meat products. Drying may be done for the single purpose of dehydrating fresh meat for the extension of storage, but it may also be one of various processing steps during the manufacture of specific meat products. Drying under natural conditions is increasingly rare. The simple dehydration or drying of lean meat under natural conditions has been practiced for centuries. Pieces of meat are cut to specific uniform shape that permits the gradual and equal drying of whole batches of the meat. Physically, the reduction of the moisture content is achieved by continuous migration of water from the deeper layers of the meat to its peripheral zone and evaporation from there into the air. Continuous evaporation and weight losses during drying causes change of the shape of the meat through shrinkage. The meat pieces become smaller, thinner, and to some degree wrinkled and darker in color. The texture also changes from soft to firm to hard. The contents of this module that we will go through includes the following: introduction and processing procedures. Drying under natural conditions is increasingly rare. Another example is the drying of meat preparations in ovens with temperatures in the range of 70 to 80 degrees centigrade to become fast-dried products such as beef sticks formed of ground, salted and flavored meat. Furthermore, for a number of indigenous meat products, moderate drying is part of the manufacturing technique with the aim of lowering the water activity, thus curbing the microbial growth. A good example is the Chinese sausage. This product becomes shelf-stable through various water activity lowering measures, namely its relatively high fat content and use of certain additives including a high sugar content in combination with drying and light smoking at temperatures of plus 50 to 60 degrees centigrade. Besides such more complex drying techniques, the simple dehydration or drying of lean meat under natural conditions has been practiced for centuries. It's still a popular method in many developing countries, in particular where no cold chain is available. It's predominantly carried out for meat preservation based on the experience that dehydrated meat will not spoil easily. Pieces of meat are cut to a specific uniform shape that permits the gradual and equal drying of whole batches of the meat. Physically, the reduction of the moisture content is achieved by continuous migration of water from the deeper layers of the meat to its peripheral zone and the evaporation from there into the air. Meat drying is a simple but efficient food preservation activity. Dried meat can be stored under ambient temperatures for many months. Due to the lower water content, microbial spoilage of the muscle proteins can be safely prevented. However, deterioration of the adhering fatty tissue through rancidity can't be stopped. It's therefore advisable to use lean meat only. Beef and buffalo meat, as well as goat and certain game meats, including the deer and antelopes, are best suited. The same applies to meat of livestock used in some regions for meat production, such as camels or yaks. The suitability of mutton is ranked slightly lower. Pork, even from very lean muscle parts, is less suitable as it contains higher amounts of the intramuscular and mostly invisible intramuscular within the muscle cells fat, which is prone to oxidation and hence turns quickly rancid. The meat is exposed to the open air and intermittent solar radiation and quickly loses substantial amounts of its tissue moisture. The drying process will be faster the shorter the distance from the center of the meat piece to its surface. In order to accelerate the drying process, in particular from the inner layers of the meat, it's therefore common practice to cut the meat in narrow strips or in flat pieces. Recommended shapes for meat pieces to be dried are strips with a rectangular cross-section of 1 into 1 cm, flat or leaf-shaped pieces with cross-section of 0.5 cm into 3 to 5 cm. Intermediate moisture foods are the foods with improved microbiological stability fabricated by reduced water activity, that is, adjusting moisture content, and by the presence of solutes. Dried meat products are the result of the simple dehydration or drying of lean meat in natural conditions or in an artificially created environment. Their processing is based on the experience that dehydrated meat, from which a substantial part of the natural tissue fluid was evaporated, will not easily spoil. Pieces of lean meat without adherent fat are cut to a specific uniform shape that permits the gradual and equal drying of whole batches of meat. Dried meat is not comparable to fresh meat in terms of shape and sensory and processing properties, but has significantly longer shelf life. Many of the nutritional properties of meat, in particular the protein content, remains unchanged through drying. For the traditional drying of meat, the natural conditions, sunshine and air circulation, are used. Two drying techniques can be distinguished, with both using prevailing natural conditions but differing in the impact of the solar energy. These techniques are called sun drying and solar drying. The basic traditional drying method is called sun drying, characterized by direct solar radiation and natural air circulation on the product. Meat pieces are cut into strips or flat leaf-shaped pieces. They are then suspended in the open air or spread on drying trays made of fiber or wire mesh with a wooden or metallic frame. For sun drying, in particular for the suspension method, the meat is sometimes dipped in salt solution, approximately 14% common salt. This helps to limit microbial growth on the meat surfaces and protect it to some extent against insects. For the traditional drying of meat, the natural conditions, sunshine and air circulation are used. Fermented dry sausage basically is manufactured by tampering and breaking the raw meat materials, formulating the meat with added cure, starter culture, salt and seasoning mixture, stuffing the product into casings, fermenting, heating, smoking, which is optional, and drying. The key considerations for manufacturing fermented dry sausage are as follows. Sausage will require 30 to 40% moisture loss. Fat simmering over lean tissue should be minimized to enhance moisture loss and product definition. Raw meat mix should be approximately 25 to 28 degree Fahrenheit, which means -3.9 to -2.2 degree centigrade when combined. Meat mix temperature at stuffing should be 25 to 30 degree Fahrenheit, which means -3.9 to 1.1 degree centigrade. Meat visual defects, for example blood clots, should be minimized since they are magnified with drying. A typical example of a fermented dry sausage formulation and process would be that of US-style pepperoni. The product is formulated to about 28 to 32% fat, figuring 68 to 70% final yield, considering a least cost formulation including predominantly pork with some beef. The maximum amount of beef allowed in product labeled as pepperoni and not beef pepperoni is 55%. Generally, most processors use a minimum 60% pork but can go to as much as 100% pork depending upon market, meat prices and if exported. Pork and beef cheek meat is commonly used, lack of bind, high protein and is allowed as meat. Finely textured beef and pork is also allowed and used due to price, but the desired texture and color prevent excessive usage levels. Summer sausage, Lebanon bologna and Thuringer are examples of fermented semi-dry sausages. These products are manufactured in much the same way as the fermented dry sausages, but with a few distinctions. In general, semi-dry sausages, as the name implies, do not lose as much water, 10 to 15% loss, as dry sausages, 30 to 40% loss. The drying occurs during fermenting and cooking, so a specific dry room is not needed. Fat and protein smearing are not as much of an issue due to less moisture loss, so formulation temperatures are higher in the average of 28 to 40 degree Fahrenheit, which means -2.2 to 4.4 degree centigrade. Most semi-dry types are cooked following fermentation and exhibit finer grind and lower pH, less than 4.8. A typical summer sausage process would include a fermentation period of 12 to 16 hours at 100 degree Fahrenheit. There are two types of fermented semi-dry sausages, that is chemically acidified sausages and non-acidified dried sausages. Some dried meat products are formulated with chemical acidulants rather than starter cultures, which accelerate the process by eliminating the fermentation period. These chemical acidulants provide a slower release of the specific acid as opposed to addition of the straight acid into the meat mix in order not to result in premature acidulation before the meat matrix is established. These types of acidified product processes are direct heated and cooked following formulation. The entire process takes 6 to 7 hours versus a 12 to 18-hour fermentation process. Some dried sausages are not fermented or acidified. This product segment includes a portion of the dried meat snacks, meat sticks, and some larger diameter sausage. These products have the same general formulation process as fermented dry sausages, but no starter cultures or acidulants are added during formulation and no fermentation period is required. Due to the higher pH, these products must be dried to a lower water activity, less moisture than fermented products to achieve shelf stability. Dried whole muscle products are mostly dry cured. This product category includes the familiar dried hams such as prosciutto, parma, and country ham, but also other dried intact pieces of meat such as dried pork bellies, pancetta, dried pork shoulders, copa, and dried beef rounds, bresaola, beef prosciutto, basturma. Most nutritional properties of meat, in particular the protein content, remain unchanged through drying. In contrast to sun drying, where the meat is exposed directly to the sun, is known to have certain disadvantages such as exposure to contamination from the sources such as dirt, wind, rain, insects, rodents, and the birds. Quality deficiencies such as changes in color or flavors, foreign contaminating substances such as dirt and sand, and even high surface microbial contamination. The solar drying methods uses indirect solar radiation. Continuous evaporation and weight losses during the drying causes changes of the shape of the meat through shrinkage. The meat pieces become smaller, thinner, and to some degree wrinkled and darker in color. The texture also changes from soft to firm to hard. Besides such more complex drying techniques, the simple dehydration or drying of lean meat under natural conditions has been practiced for centuries. It's still a popular method in many developing countries, in particular where no cold chain is available. An initial process for manufacturing whole muscle products consists of dry mixing the non-meat ingredients with the meat, pickle curing by immersing the meat pieces in concentrated brine, or injection curing by injecting the brine. Injection curing is less common since the water in the brine must be later removed during drying. After the initial salting, the product is held for some period of time at refrigeration temperatures for salt and cure penetration, burning period. The product undergoes a maturation period, air drying and smoking if desired, and storage. The final product is either then sliced and packaged for sale or sold in the whole piece form for slicing by the final customer. A variety of other meat snacks such as meat sticks, kippered beef, and assorted chopped and formed or ground and formed products are manufactured similar to sausage type products. These can be considered a type of dried, fermented or not fermented sausages where Manufacturing differences are the particle size and final product form, round, flat, etc. Most dried meat snacks have a much lower moisture content, 22 to 24%, water activity less than 0.80, and moisture protein ratio 0.75:1 or less than other products that we have discussed. Typically, the final yield is only about 45 to 55% from the original marinated or injected product. Many parameters are monitored in the formulation and processing of shelf-stable dried meats. Most of these are control points for product quality, total contamination, relevant meat pathogens. Only a few are true critical control points for product safety. The following parameters may be monitored: microbiological monitoring, raw materials, in-process final product, total contamination, relevant meat pathogens, moisture content and moisture protein ratio, water activity, pH, initial of the meat mix, rate of change with time, titrable acidity, and the product weight. Air circulation velocity and uniformity throughout the process, temperatures, environment, product, relative humidity during process. Most often, shelf-stable dried meat products rely on a combination of the characteristics to achieve shelf stability, and these are low pH, high acidity, low water activity, inherent microflora and starter culture in non-cooked products. Packaging helps prevent contamination and spoilage due to mold, yeast and undesirable lactic acid bacteria. Pathogens will not grow if the contamination occurs, and they may even die off in these products at room temperature. So students, let's now summarize what we have learned in this module. Meat drying is a simple but efficient food preservation activity. Dried meat can be stored under ambient temperatures for many months. Due to the low water content, microbial spoilage of the muscle proteins can be safely prevented. However, deterioration of adhering fatty tissue through rancidity can't be stopped. It's therefore advisable to use lean meat only. Beef and buffalo meat, as well as goat and certain game meats, including the deer, antelopes, are best suited. The same applies to meat of livestock used in some regions for meat production, such as camels or yaks. The suitability of mutton is ranked slightly lower. Pork, even from very lean muscle parts, is less suitable as it contains higher amounts of intermuscular and mostly invisible intramuscular within the muscle cells fat, which is prone to oxidation and hence turns quickly rancid. For large-scale or commercial meat drying operations in rural settings, improved approaches have been developed using solar drying.
So dear students, now you know different technological aspects of intermediate moisture as well as dried meat product. Now comes to the next topic, that is related to the poultry, and therein the most important process at the initial stages are inspection as well as pre-slaughter care. So these aspects will be known to you in the next module. Thank you.